David Lewis, 50 year higher level maths. This lesson is on trigonometry. Specifically, we're going to be talking about functions, and we're going to be doing some recap on the formulas that we've learned previously and over the last number of weeks to really set us up to look at some past paper questions. Okay, so this question that we're doing here is all based around a trig graph, as you can see behind me. This question itself is on page 138 of your notes. It's a previous mock question, so it is quite good, and it's probably more like the question you would see in a Leaving Cert exam. A little bit easier than the ones we have been working on, so it's really going to center you and see like where we're at in terms of trig functions itself. Okay, to be honest with you, at the very beginning of this question, there's nothing really to do with trigonometry, but actually then setting yourself up really makes the question itself easy. So if I give it a read here, so again, page 138, I've painstakingly drawn this on the board here, so it's probably better to refer to the diagram just because of the different numbers, the diagram's in your notes, but I have it on the board here and I'm going to be working from that. It says, in an area of North America, the population of grey wolves and elks was monitored every month for a period of 2 years. It is known that elks represent the main prey for wolves in the area. The results are shown on the graphs below. So instantly from looking at this, I can see that these are trig graphs, two separate ones here. The reason I can see they're trig graphs is because they're sinusoidal. They keep repeating themselves again and again and again. And we know, like automatically, when we look at a trig graph, that there's a couple of things that we should do. First thing is, we should find its midpoint. Then I always like to look to see, right, where is the period? How long does it take to go through one rotation or one shape? And then I kind of just like to note to myself, what of our main four graphs actually is it? So which one of the four is the graph up there? And they might not even ask you for it, but you can probably bet that somewhere down the line, they're going to ask you for the function. They're going to ask you to do the function. So without even reading the question, if I look at my graph over here, if I just focus on the elks for a second, so forget the blue one with the wolves, just focus on the elks. Okay, the first thing I want to do is draw a midline. So I check how far up it goes and I check how far down it goes. If you look at your notes there, it goes from 14.5 down to 7.5. Okay, if I find the midpoint of that, so if I take those numbers away from each other, the difference, and I get 7, then I divide by 2, which is 3.5, and then I add it on, or I subtract from the top one, I can find the midline there. So there's different ways of looking at it, but you can do it your own way. But I found that the midline of the elks was at 11, and I'm going to actually physically draw that on my graph as a dotted line, because that's going to help me in a few minutes' time. Next thing I do is I look for the period. How long does it take to get back to where it started? So this graph here started at the top, went down, up and around, okay? And I know it doesn't exactly look it on my graph there, but if you draw a line down from that, you can see that the period of this elk graph is 12 months. So the period is 12. Okay, so it's repeating itself every 12 months. Cool. And then I'm just going to have a look at it as well. What one of our four graphs is it? Well, it's not starting on the midline, so it's not sine, so definitely cosine. And because it's starting above the line, I can definitely say that it's positive cosine. Remember, if it started below the line, that would be negative cosine. Cool. So I'm going to leave that there for now. Remember, that's just for me. I'm probably going to use that later on. And then if I have a look at the wolves graph, so ignore the elks. Let's look at the wolves here. So the wolves is the blue line. It starts at 9, but then it goes up to 11, and then it goes down. Just better check the graph here. So up to 11 and down to 7. That's fine. Okay, so if I went to go ahead and draw its midline, the midpoint between 11 and 7 is actually 9. So I draw a midline across there, and then I ask myself, okay, what's its period? Now its period actually ends up being the same. Again, it probably doesn't look like it on my graph, but starts at the middle, goes up, down and around. Okay, and if you go down and you use your graph here, you will see that the period is actually 12 months there. Okay, then you got to ask yourself, what shape is it? What shape is it? And because it's starting at the midpoint, it's definitely sine, and because it goes uphill, it is definitely positive sine. So again, I'm just writing them up for myself, setting up the graph for kind of what I know is to come. Okay, then if we actually look at the questions, question 1 says write down. So basically it's saying write down. There's no calculations here. So they're not asking you, sometimes the easier questions, particularly the stronger students, think that, you know, when it says write down, it's some sort of trick here. Now this is literally an easy question to ease you into it. That always happens in Leaving Cert questions, and this being a mock question is no different. Write down the starting population of both wolves and elks. Okay, so write it down. So if you go to your graph and you have a look, the starting population, remember the population is in hundreds. So if you have a look at the elk, there the elk, make sure you say which one's which, is 1450. And then if you look at the wolves, you can see that it's 900. So absolutely no problem with that first part of the question there, not even trigonometry, potentially sixth class maths or whatever. Part 2. For how many months each year was the population of wolves higher than that of elks? Now something I didn't mention here, but we might have noticed, is this graph actually talks about 2 years, so 12 months and then another 12 months. Be careful here, it says for how many months each year. So we're only going to look at 1 year. Was the wolves higher than that of elks? So if you look at your graph here, where they cross over, here and here, that period there, that small period in between those 2 points, the population of wolves is higher than elks. Okay? And it does happen again a second time, but remember that's a separate year. So if we go down on our graphs here and we read off the months, well, the wolves started to be a higher population in month 3 and then finished, they crossed over again in month 7. So 7 minus 3 is equal to 4 months. And the mistake here, we're going, oh, I got 4, let's multiply it by 2 because it happens again. No, don't do that, I said each year, so just be very careful about that. Okay, so again, nothing here, not really even trigonometry, but still, all good. Next page then. So page 139, part 3 says, estimate. So we've definitely talked about that word estimate before, estimate. It doesn't have to be exactly accurate, it's almost like an informed guess. Okay, it says estimate from the graph the greatest difference between the populations of wolves and elks in any year. So the greatest difference between them. Okay, so what one population is versus the other one, but which month has the biggest difference. Now the examiner, whoever's made this question, has gone out of their way to avoid using the word maximum because you'll think about calculus straight away. And this is not a calculus question, okay? You can actually do it using calculus and you actually do get the same answer. Okay, you can differentiate, put it equal to 0, but that's not what they're looking for. Estimate from the graph. You actually, in fact, have to use the graph because they've said from the graph. Okay, this is actually a 5-mark question, so 5 marks from this. And if you actually go through the graphs here, you will see actually at month 11 is the biggest difference between the two. And at month 11, if you go ahead and take away your 2 numbers there, so at month 11, I'll just put in for you, we have 1400 elk and we have 800 wolves, which is a difference of 600. That's actually your answer, and that's the answer you would get even if you used calculus on this. However, in this, if you couldn't spot that, if you showed the examiner, you knew a method of going ahead and trying to solve this, you knew what they meant by a difference between them. If you show them any month, so say for example, if you just took month 1, even though it's incorrect, but you took month 1, and in month 1 there was 1400 elk, and there was 1000 wolves, and you got an answer of 400. If you just subtracted any months from each other in terms of the elks and the wolves, you ended up getting the lower partial credit. So you got 2 out of the 5 marks. If you subsequently did any second month, because you showed the examiner you knew they were trying to compare months, so say you did the exact same with month 2, and even though it wasn't correct, you actually get the higher partial credits. That would be 4 out of 5 marks. Okay, now hopefully if you got that far, you would actually realise, let's look for the biggest gap in between the 2 here, or you'd continuously go for the 12 months. But just if you didn't spot it, very easy here to get partial credits. But the original one is the full mark, 5 out of 5. And we're 3 questions in. We haven't actually done any trigonometry apart from our own setup here. And then part B is where the proper trig comes in. Okay, now it wouldn't be asked like this on a Leaving Cert exam because they've asked you, as we'll see in a second, to find 2 functions. They were both worth 10 marks on this mock exam. 10. Okay, so that's a lot. Okay, so it's 20 marks to this. Imagine you couldn't do trig functions. You're out of luck. So usually what happens is they won't ask you something that can punish you twice. They would only ask you for 1. But on this question, they asked us for the functions of both of these animals here. So the population of each animal can be modelled by a trig function. Sure, we know that. Write down a function that models the population of elks after t months. Okay, so write down a function for elks. Now, whenever we are asked to write down a function, we know straight away we're going to base it around this. We're going to base it around our a sine b of x plus c. Okay, and we know we have to fill out 4 things correctly. We have to fill out a, b, c, and we have to make sure we get our shape correct. It's not always going to be sine, that's just the generic one we look at. Okay, I also have told you numerous times, we've seen this numerous times in the past, that we're going to first of all have a look for c. We're going to have a look for the midline. That's our first port of call. Our second port of call is a. Okay, and we'll discuss what that is in a second. And then after we get the shape right, our third port of call is going to be b. Okay, so if we have a look for c, c is the midline. What are we dealing with here? We're dealing with elk. Okay, now if you go back to your graph over here, we actually know a little bit about elk already. We know, and we have drawn its midline at 11. That red dotted line there, that's its midline. Okay, so that can go in for c. Grand. If you do that and you put it in, you've passed the question. You get 1 out of those 4 correct, that's 4 out of 10 marks. 4 out of 10 marks. If you get 2 correct, that's 8 out of 10 marks. Let's go for a. Remember, a is what we call the amplitude. So it's how far above or below the midline the graph goes. So if we're starting at 11 here, it starts at 11 and it goes all the way up to 14.5. So our amplitude is 3.5. Okay, so our a, amplitude, a, is 3.5. Grand. Now let's just check our shape. What's our shape? Well, we've already determined earlier that our shape is actually cos. So I'm going to note that to myself. It's cos, positive cos. And then looking for b, well, b is the weird one. B is where we take a full circle, which can either be 360 degrees or 2 pi, and we divide it by the period. We've already found the period is 12, so how long it takes to go through one rotation or one shape. So if we take a full circle and divide by 12, we've gotten b. Now, because this is a practical example, we're dealing with real life situations, we should use radians. So we should use pi. So we should use 2 pi. So for a full circle, divided by the period, that's going to give us b. So our full circle here is 2 pi, and we divide it by 12, and that gives us pi over 6. And if we want to go ahead and put them back together, that will complete our answer. So our full answer here is 3.5 times, it's not sine, so it's cos pi over 6. Instead of x, remember real life example, we're talking about the period being in time, so t and then plus c, so plus 11. And that's a function for the population of elk. Now we know from that population here, if we put in anything for time, if we put in 12 months for time, that's actually going to give us what we got in our graph. If we put in 15 months for time, that will tell us the population of elk after 15 months. So that function is absolutely crucial. And we're actually going to solve things like this in next week's classes and show how we can actually work out for all, like if we have the population, how we can work out the different times for them. Okay, but for now, all we're looking at is filling this out from our graph. Okay, so it's actually exactly like the idea we had with the blood pressure question, where we sketched the graph and then went backwards. So knowing this trick going from graph to function and backwards is absolutely crucial. Part 2 says, write down a function that models the population of wolves after t months. So the same stuff, but just with wolves here. Okay, so it might be a good time now just to pause the video and make sure you can get the wolves. It's the exact same as this. If not, I'm going to go through it now, but it might be a nice idea to pause it. Make sure you can get the function for the wolves. Okay, dealing with the wolves is absolutely no difference. We're okay to go this side of the board? Yep. Okay, so for wolves here, again, I always just follow the same process. Once you get good at this, you probably don't need to write all these things down, but I always follow the same process. I know I need to find A, B, and C, and I know I need to get the shape. Okay, so looking at our diagram from wolves over there, our C, our very first thing, our C is 9. We found that at the start, almost automatically, like a reflex. Our A is going from the midline up to how high it goes. So it's 9 is the midline, as high as it goes is 11. So our A here is 2. Grand. Our shape, well, we actually said our shape was sine, so that's fine. And then b is a full circle, so again 2 pi over the period, which is 12. So they actually have the same b here. Grand. And then we plug it back into this here. So 2 sine pi over 6 t plus 9. And there we go. And that's that there. So 20 marks for that in the mock. Probably not 20 marks in the leaving cert, usually 10 marks, but very, very, very important. If you just look at this last part here is more an idea towards our leaving cert. Okay, so it's not so much that I care about it too much in trigonometry right now. This last part is obnoxious project maths, okay? On every single paper, there's going to be a couple of these final parts, these final 5 markers that the examiner uses to separate H1 students out from everybody else. Basically, they put them on the paper and they actually do not want you to put anything down. They want students to get 0 so they can knock off the number of H1 students that there actually are. And you can recognize these questions very quickly in trigonometry or stats or even probability with a whole load of wording. Okay, so there's an absolute onslaught of words here on the top of page 140. Okay, so after all this, it's been great so far. For the last 5 marks, don't let this throw you. I'm just putting it on your radar. If you have this, I'm very, very happy. We've given the functions a really, really good go. One of the researchers states that the total population of the 2 animals, the combined number of elks and wolves, after 3 months could also be represented by a trigonometric function. He states that the period of this function would be exactly the same as the period of each of the 2 individual population functions identified in parts 1 and 2. He also states that the maximum value of this function will be equal to the sum of the maximum values of the 2 individual population functions. Okay, again, what is that? Designed to make you just go, nah, not for me. So potentially, just pause the video, give that another read, see if you can understand it. Then it says, part 3, do you agree with his statements about the period and maximum value? Explain your answer. The whole idea here is you agree or you disagree, or you agree with one or disagree with the other. So basically, if you don't know, let's just say one or the other and try back it up. Okay, if you were going for a H1 on a leaving cert level, okay, with this time next year, you really, when you're attacking a paper, want to get no questions where you get 0. It's very easy to get partial credits here. Remember, this is only 5 marks. If you give it a bash, you'll probably get 2 or 3. Okay, so 2 or 3, because most people aren't going to even attempt this. In this question, which is, it's not the same idea, is not going to come up again. The idea of being confused will come up again. Okay, in this question, what they're saying is, if somebody took all the numbers of all the elks and wolves and put them together, they would form their own function. So they would form their own combined function like that. Okay, and basically what the guy is saying here, he is claiming that the period will be the exact same. Okay, so the period will be the same. Now we actually found that the periods of these 2 functions are the same as well, how long it takes to go through one shape. And I don't dispute that, so I agree with his period statement. I think the period would be the same, because it's going to be a different shaped graph, but it's going to come to a halt after 12 months every single time, like the 2 there. So that's fine. Okay, but he also states the maximum value of this function will be equal to the sum of the maximum values of the 2 individual population functions. So if we have a look here, what he's saying is, if we added these 2 together, the maximum value of the combined function would be equal to 14 and a half, so however high the elks go, so 14 and a half plus 11. Okay, so it would be up to 25 and a half. That's what he's saying once you get this combined function. And I actually disagree with that, because you can see quite clearly from this graph that at no stage, no particular time are the maximums at the same point, at the same time of year. Okay, so at no time. So what I'm saying is, I agree with the period, I disagree with the adding the numbers together to get the maximum. Okay, because it's not going to happen at the same time. Okay, again, not a massive deal, only 5 marks for that piece there. The rest of it though, massively important. There was no trig functions question in the 2019 paper, even though trigonometry, as we'll see in the next video, was absolutely crucial. It was huge. There was 2018, 2017, 2015, 2014. So knowing this and knowing this idea in particular is very, very, very beneficial for us for our leaving cert. What else do I want to say with this? Okay. In the second part of this video, just the next couple of minutes, I just want to recap the tools that we have. Here's one tool that we've learned in trigonometry, one tool so far. And now after that, I just want to talk about things that we would have mentioned before the mock and before midterm. So, first thing we said to ourselves was, okay, there's a lot of stuff at junior cert. There's a lot of stuff at junior cert that is applicable to leaving cert. At junior cert, we were dealing with right angle triangles. Okay, so we call them RATs, so right angle triangles. And at leaving cert, that's our first question. Is it a right angle triangle? And if it is, we can go ahead and we can use Pythagoras, where we have two sides of a triangle looking for a third. Or we can use our SOHCAHTOA. Great. Now, this, I've got you to go home and I've got you to recap again twice since we went ahead and did it. And we have to be familiar with that. You're going to be shocked about how in our next video, this is going to be so crucial for our leaving cert higher level maths. If it wasn't a right angle triangle, if you weren't sure, if you can't assume it, or you can't assume it, so if you can't say for definite it's a right angle triangle, well then you ask yourself a further question. You said, is there a pair? As in that triangle we're dealing with, is there an angle and a side across from it? So is there a pair? If the answer was yes, if there was a pair, you could see a pair, well then we were going to go ahead and use the sine rule. And if the answer was no, we were going to go ahead and use the cosine rule. Now they're in your formula and tables booklet, that's completely fine. Okay, that's fine. Actually, all of those are in your formula and tables booklet on page 16. The other tools we learned, which are also actually on page, well, one of them is on page 16, the other one's on page 9, was to find the area of a triangle. Okay, so the area of a triangle, we looked at the leaving cert version of this. We had half the base by the perpendicular height, but at the leaving cert we said we were going to look at half AB by the sine of C. So half two sides and the angle in between. The angle had to be in between them. Also very, very important, but again also on page 16. Another tool we learned was, well, you could actually measure angles in degrees or you can measure angles in radians. And if you wanted to convert one to the other, which could be beneficial if, as we would have seen on certain questions, if you wanted to convert one to the other, maybe if they asked you for an answer in a certain way, like they did in the 2019 paper, which actually threw a few people. But if they asked you for one in a certain way, there's two multiplications. If you were trying to turn something from radians into degrees, we multiply by 180 over pi. If you were trying to turn something the other way, if you were trying to turn something from degrees into radians, so degrees into radians, you multiply by pi over 180. The way I personally remember it is whatever is on top is whatever you're going to get. So in this case, we've got degrees on top, we're going to get degrees. In this case, we've got radians on top, or the pi representing radians, so we're going to get radians. So that was another tool we learned. We also spoke about sectors, and we spent a good bit of time on sectors and what they were, and we said that in your formula and tables booklet for sectors, there's formulas for the area and for the length. Okay, so if you look at this sector here, which is just a part of a circle, remember these are radii, we could either find the area or we could find the length of the arc along here. So we could find the area, the length of the arc, and again, there was actually two formulas, so area and length, but one for degrees and one for radians. Okay, so they're in your formula and tables booklet on page 9. Okay, so page 9 and page 16 are crucial for trigonometry in your leaving cert. Okay, in terms of last year, in terms of 2019, before we wrap this video up and I give you a little bit of homework, trigonometry itself, just to put this frame in mind, how this is an absolute massive opportunity for you. This trigonometry questions on trigonometry were worth 130 out of 600 marks last year. Now it's not all trigonometry, but that is, 21% of your leaving cert for the stuff we are learning now. And to have this on video, to have this opportunity to lay down a marker on that is huge for you. So I really implore you to make sure you got this down. If not for fifth year, just to help the future you out in sixth year. Because 21.6, so round up 22% of your leaving cert for questions involving trigonometry. In terms of homework, questions that I would like you to try based on this video and based on these skills, so the recap of these skills and the functions over there, I would like you to try on page 42, so page 42, question 5.6, and on page 142, page 142 after that, it's actually the question from the 2010 Leaving Cert. So from the 2010 Leaving Cert, we have it in there as question 2, or maybe it was, I think it was question 2 part B, and it was from Leaving Cert 2010. But both of those are in your notes, and I'd implore you to give those a shot, see how you get on, and in a couple of videos time we will be going through them. So make sure you give them a go before you watch the next few.